Have you wondered just how far away the edge of our solar system really is? Or maybe you've heard about Pluto, that tiny, icy world way out there, and thought, how long would it actually take us to get there? Today, let's take a journey together and find out. If you are ready to embark with me in this journey, subscribe to the channel and hit the like button. Your support is very important to me. Now let's get started. Let's start with a simple question. How far away is Pluto? Pluto isn't always the same distance from Earth. Both Earth and Pluto travel in long, stretched-out orbits around the Sun, so sometimes they're a bit closer, and sometimes they're much farther apart. But on average, Pluto is about 3,670,000,000 miles from us. That's 3.5 billion miles, or about 5.9 billion kilometers. To put that in perspective, if you could somehow drive a car straight to Pluto at 60 miles per hour, it would take you more than 6,900 years to get there. That's longer than all of recorded human history. But of course, we don't drive to Pluto. We use spacecraft. And that brings us to one of the most exciting chapters in space exploration, the journey of New Horizons. Back in January of 2006, NASA launched the New Horizons spacecraft. Its mission? To explore Pluto and the Kuiper belt, which is a region of icy bodies beyond Neptune. New Horizons was built to be fast, really fast. At launch, it was the fastest spacecraft ever sent from Earth, traveling at about 36,000 miles per hour, or nearly 58,000 kilometers per hour. But even at that incredible speed, the journey to Pluto was no quick trip. New Horizons took 9.5 years to reach its destination, finally flying past Pluto in July of 2015. That's right, 9.5 years, traveling at tens of thousands of miles per hour, just to reach a world at the edge of our solar system. So, if you're wondering how long it would take us to reach Pluto, the answer really depends on how fast we can go. With the technology we have right now, it takes nearly a decade. But what if we could go faster? What if we could use new propulsion methods, or even imagine technologies that don't exist yet? Before we dive into those possibilities, let's just pause for a second and appreciate how far New Horizons actually traveled. The distance from Earth to Pluto is so huge that even light, the fastest thing in the universe, takes about 4.5 hours to make the trip. That means when New Horizons sent back its first close-up images of Pluto, we had to wait nearly 5 hours for the data to reach us. It's a reminder of just how vast our solar system is, and how even our fastest machines are still crawling compared to the speed of light. But scientists and engineers are always looking for ways to go faster. So, let's explore some of the ideas that could one day shorten the journey to Pluto, and maybe even take us beyond. Right now, chemical rockets are our main way of getting spacecraft into space. These rockets burn fuel to create thrust, pushing the spacecraft forward. The speed a rocket can reach depends on how much fuel it carries and how efficiently it burns that fuel. But there's a limit. Rockets can only carry so much fuel before they become too heavy to launch. New Horizons used a powerful Atlas V rocket and even got a boost from Jupiter's gravity to reach its high speed. Even so, it still took nearly a decade to reach Pluto. Other missions, like Voyager 1 and Voyager 2, used similar methods to reach the outer planets and beyond. Voyager 1, which launched in 1977, is now the farthest human-made object from Earth, but it took decades to get there. If we ever wanted to send humans to Pluto, the journey would be even more challenging. We'd need to carry food, water, and supplies for a trip that could last over a decade, and we'd have to protect astronauts from cosmic radiation and the freezing cold of deep space. So, are there any new technologies that could help us reach Pluto faster? Scientists are working on several ideas, and some of them sound like science fiction, but they're based on real physics. One idea is ion propulsion, which uses electricity to accelerate charged particles and create thrust. Ion engines are much more efficient than chemical rockets, but they produce less force, so they're best for long, slow journeys. NASA's Dawn spacecraft used ion propulsion to visit the asteroids Vesta and Ceres. It wasn't as fast as New Horizons, but it could keep going for years without running out of fuel. Another idea is solar sails, which use the pressure of sunlight to push a spacecraft forward. The Japanese spacecraft Ikaros tested this technology in 2010, and it worked. Solar sails could one day send small probes to the outer solar system without using any fuel at all. Some scientists are even exploring nuclear propulsion, which could use the energy from splitting atoms to create powerful thrust. This technology could cut travel times to Pluto in half, but it comes with big engineering and safety challenges. And then there are the truly wild ideas, like using lasers to push tiny spacecraft at a fraction of the speed of light. Projects like Breakthrough Starshot are exploring these concepts, hoping to one day send probes to other stars. What would it take to reach Pluto in just a few years, or even a few months? Could we ever build a spacecraft that travels close to the speed of light? And what would we find if we could explore Pluto up close, not just with robots, but with human eyes? Pluto is more than just a distant, icy world. It's a time capsule from the early solar system, holding clues about how planets and moons formed billions of years ago. The New Horizons mission revealed a world full of surprises: mountains made of water ice, vast plains of frozen nitrogen, and a thin, blue atmosphere. Studying Pluto helps us understand the Kuiper belt, a region filled with thousands of icy objects that may hold the secrets to the origins of our solar system. Exploring Pluto also connects us to the bigger story of the universe. Every atom in our bodies was forged in the hearts of stars, and the questions we ask about distant worlds are part of a shared human adventure. When we reach out to places like Pluto, we're not just exploring space. We're exploring what it means to be human, to wonder, and to seek answers. Will we send another mission to Pluto? Could we land on its surface, or even explore the mysterious ocean that might lie beneath its icy crust? The future is full of possibilities, and the story of Pluto is far from over. If you're enjoying this journey through the cosmos, don't forget to subscribe to the channel and give this video a like. It really helps us reach more curious minds like yours, and it lets me know you want to see more videos about the wonders of our universe. So, let's imagine for a moment that we could actually build a spacecraft that travels much faster than anything we've ever launched before. What would that look like? And what would it mean for our journey to Pluto? First, let's talk about the fastest things we've ever sent into space. After its flyby of Jupiter, New Horizons reached a speed of about 31,000 miles per hour relative to the Sun. That's incredibly fast by human standards, but in the grand scheme of the solar system, it's still pretty slow. If you could somehow keep accelerating, you'd eventually reach a point where you're moving so quickly that even the vast distances between planets start to shrink, at least from your perspective. But here's the thing: getting to those speeds is really, really hard. The more fuel you carry, the heavier your spacecraft becomes, and the more energy you need just to move that extra weight. It's a bit like trying to run while carrying a backpack that gets heavier every time you take a step. That's why most of our spacecraft use clever tricks, like gravity assists, to pick up speed without burning more fuel. Gravity assists are one of the coolest tools in our space exploration toolkit. Imagine you're playing a game of cosmic pinball. You send your spacecraft flying past a planet, and the planet's gravity slingshots it forward, giving it a boost in speed. That's exactly what New Horizons did with Jupiter. By flying close to the giant planet, it picked up an extra 9,000 miles per hour, shaving years off its journey to Pluto. Without that gravity assist, the trip would have taken much longer. But even with gravity assists, we're still limited by the technology we have today. Chemical rockets can only do so much. That's why scientists are always looking for new ways to push the boundaries. Let's talk a bit more about ion propulsion, because it's one of the most promising technologies for deep space travel. Instead of burning fuel in a big, explosive burst, ion engines use electricity, often generated by solar panels, to slowly and steadily accelerate ions, which are tiny charged particles. The thrust is gentle, almost like a soft breeze, but it can keep going for years. Over time, that steady push adds up, and the spacecraft can reach impressive speeds. The Dawn mission is a great example. Dawn used ion propulsion to visit two different asteroids, Vesta and Ceres, in the asteroid belt. It wasn't the fastest spacecraft ever, but it was able to change its orbit and visit multiple destinations, something that would have been impossible with traditional rockets. If we could scale up ion propulsion, maybe with a nuclear power source instead of solar panels, we could send probes to the outer solar system much more efficiently. Now, solar sails are another fascinating idea. Picture a giant, ultra-thin sheet, almost like a sail on a boat, but instead of catching wind, it catches sunlight. Photons, the tiny particles of light, don't have mass, but they do have momentum. When they hit the sail, they push it ever so slightly. Over time, that push can accelerate a spacecraft to high speeds, especially in the emptiness of space where there's no air resistance. The Japanese Icaros mission proved that solar sails can work. Icaros unfurled its sail in space and used sunlight to change its trajectory. In the future, we could build even bigger sails and send tiny probes racing out to the edge of the solar system, or maybe even to other stars. The beauty of solar sails is that they don't need fuel, just sunlight. But what if we want to go even faster? That's where nuclear propulsion comes in. There are a couple of different ways to use nuclear energy for space travel. One is nuclear thermal propulsion, where you use a nuclear reactor to heat up a gas, like hydrogen, and blast it out the back of the spacecraft. This can provide much more thrust than chemical rockets, and it's much more efficient. Another idea is nuclear electric propulsion, where a reactor generates electricity to power ion engines. Both of these methods could dramatically cut down the time it takes to reach Pluto. Instead of 9 or 10 years, maybe we could get there in 4 or 5. But building and launching nuclear-powered spacecraft is complicated. There are safety concerns, political hurdles, and lots of engineering challenges to solve. And then, there are the really wild ideas. Concepts that sound like science fiction, but are being seriously studied by scientists today. One of these is laser propulsion. Imagine a tiny spacecraft, no bigger than a smartphone, with a shiny sail. On Earth, we build a massive array of lasers and fire them at the sail, pushing it to a fraction of the speed of light. Projects like Breakthrough Starshot are exploring this idea, hoping to one day send probes to nearby stars like Proxima Centauri. If we could adapt this technology for our own solar system, we might be able to send tiny probes to Pluto in just a few months. Of course, there are huge technical challenges. Keeping the sail stable, aiming the lasers accurately, and communicating with a probe that's racing away at incredible speeds. But the potential is there, and it's exciting to think about. Now let's step back for a moment and think about why we want to go to Pluto in the first place. What makes this distant, icy world so interesting? For a long time, Pluto was just a faint dot in our telescopes, a mysterious outpost at the edge of the solar system. But when New Horizons arrived, it revealed a world full of surprises. Pluto has mountains made of water ice, taller than the Rockies. It has vast plains of frozen nitrogen, shaped by strange, unknown forces. There are hints of glaciers, possible cryovolcanoes, volcanoes that erupt ice instead of lava, and a thin, blue atmosphere that glows in the sunlight. Some scientists even think there might be a hidden ocean beneath Pluto's icy crust, kept warm by the heat of radioactive elements deep inside. Every discovery at Pluto raises new questions. How did such a small world end up with such complex geology? What's happening beneath the surface? Could there be the building blocks of life, or at least the chemistry that leads to life, hidden in the darkness below? And Pluto isn't alone out there. It's part of the Kuiper belt, a vast region beyond Neptune filled with thousands of icy objects. These are the leftovers from the formation of the solar system, the building blocks that never became planets. By studying Pluto and its neighbors, we can learn about the early days of our solar system, how planets formed, how they migrated, and maybe even how life began. But there's another reason to explore Pluto, and it's a bit more personal. When we send a spacecraft to the edge of the solar system, we're not just collecting data. We're reaching out, as a species, to touch the unknown. We're asking questions that have no easy answers, and we're daring to imagine what might be possible. Think about it. Every atom in your body was forged in the heart of a star. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was created in cosmic furnaces billions of years ago. When you look up at the night sky, you're seeing your own origins written in the stars. And when we explore places like Pluto, we're exploring a part of ourselves. Now, you might be wondering, what's next for Pluto? Will we ever go back? The answer is, we hope so. Scientists are already dreaming up new missions. Maybe an orbiter that could circle Pluto for years, mapping its surface in detail, or even a lander that could touch down and study the ice up close. Some proposals even imagine sending a probe to melt through the ice and search for that hidden ocean. But these missions are tough. Pluto is far away, it's cold, and it takes a long time to get there. Every mission is a huge investment of time, money, and creativity. But the rewards are just as big. Every time we reach a new world, we learn something that changes the way we see the universe and ourselves. And here's something to think about. The more we learn about Pluto, the more we realize how much we don't know. That's the beauty of science. Every answer leads to new questions. Every discovery opens up new mysteries. It's a never-ending journey, and we're all a part of it. So, how long would it really take us to reach Pluto? With today's technology, it's a journey of nearly a decade. With new propulsion methods, maybe we could cut that down to a few years. And with the wildest ideas, who knows? Maybe one day, we'll send tiny probes racing across the solar system in a matter of months. But no matter how long it takes, the journey is worth it. Because every step we take into the unknown brings us closer to understanding our place in the universe. It reminds us that we're all explorers, all made of stardust, all connected by the same questions and the same dreams. You might be wondering, what would it actually feel like to travel all the way to Pluto? Imagine you're an astronaut, climbing aboard a spacecraft designed for the longest journey any human has ever attempted. The countdown begins, engines roar, and you're launched away from Earth, leaving behind everything familiar. At first, you'd see our planet shrink to a blue dot, then the Moon, then Mars, and eventually, even the Sun would start to look like just another star in the sky. The trip would be long, much longer than any mission we've ever attempted. Even with the fastest spacecraft we've built so far, you'd be traveling for nearly a decade. That's 10 years of living in a tiny, artificial world, surrounded by the emptiness of space. You'd have to bring everything you need with you: food, water, air, and all the supplies to keep you healthy and safe. And you'd have to be ready for the challenges of deep space, cosmic radiation, microgravity, and the psychological effects of being so far from home. But imagine the view as you approach Pluto. After years of travel, you'd finally see that distant world growing larger in your window. You'd see its icy surface, its mysterious mountains, and maybe even the thin haze of its atmosphere. You'd be the first human to set eyes on a place that, until recently, was just a blurry dot in our telescopes. Of course, sending humans to Pluto is still a dream for the future. Right now, our robotic explorers are doing the hard work of blazing the trail. But every mission we send teaches us something new about how to survive in deep space, how to build better spacecraft, and how to solve the problems that come with exploring the unknown. Let's talk a bit more about the Kuiper Belt, because Pluto is just one member of a much larger family. The Kuiper Belt is a vast region beyond Neptune, filled with icy bodies left over from the formation of the solar system. Some of these objects are as big as Pluto, or even bigger. Others are small, just a few miles across. Together, they form a kind of cosmic time capsule, preserving the conditions that existed when the solar system was young. When New Horizons flew past Pluto, it didn't stop there. After its historic flyby, the spacecraft continued deeper into the Kuiper Belt, heading for another object called Arrokoth. In January of 2019, New Horizons made a close pass by Arrokoth, revealing a world unlike anything we'd ever seen. a contact binary, two icy bodies stuck together, shaped like a snowman. This was the most distant object ever explored by a spacecraft, and it gave us a glimpse into the building blocks of planets. Every time we visit a new world, we're reminded of how much there is left to discover. The Kuiper belt is full of mysteries. Some objects have strange orbits, tilted or stretched out in ways that don't quite fit our models. Some scientists even think there might be a hidden planet, sometimes called Planet 9, lurking far beyond Pluto, its gravity tugging on the orbits of distant objects. We haven't found it yet, but the search is on. And that's one of the most exciting things about astronomy. The more we look, the more surprises we find. Our understanding of the solar system is always evolving. Not long ago, Pluto was considered the 9th planet. Then, as we discovered more and more objects like it, astronomers realized that Pluto was just the first of a whole new class of worlds, the dwarf planets. In 2006, the International Astronomical Union redefined what it means to be a planet, and Pluto was reclassified. Some people were disappointed, but in a way, it made Pluto even more interesting. It became the gateway to a whole new frontier. Let's not forget the human side of this story. The New Horizons mission was the result of decades of work by thousands of scientists, engineers, and dreamers. They faced setbacks, budget cuts, and technical challenges, but they never gave up. When New Horizons finally reached Pluto, people all over the world watched as the first images came in. For a moment, we were all united by a sense of wonder, a reminder that, no matter where we come from, we all share the same sky. One is to send an orbiter, a spacecraft that could circle Pluto for years, mapping its surface, studying its atmosphere, and maybe even dropping small landers onto the surface. Another idea is to send a probe that could land and dig into the ice, searching for clues about Pluto's history and maybe even signs of a hidden ocean. These missions would be challenging. The distance is huge, the environment is harsh, and the technology would have to be incredibly reliable. But the rewards would be just as great. Every new mission would bring us closer to understanding how planets form, how they change over time, and maybe even how life begins. And who knows, maybe one day, we'll send humans to Pluto. It might sound impossible now, but so did landing on the moon, or sending a rover to Mars, or flying a spacecraft past every planet in the solar system. Every great achievement in space started as a dream, an idea that seemed out of reach, until someone decided to try. As we look to the future, it's important to remember that exploration is a journey, not a destination. Every question we answer leads to new mysteries. Every discovery opens up new possibilities. The universe is vast, and we've only just begun to explore it. So, the next time you look up at the night sky, remember that you're part of a story that stretches across billions of years and billions of miles. The atoms in your body were forged in stars, scattered across the galaxy, and brought together by the forces of nature. You are, quite literally, made of stardust. And when we reach out to places like Pluto, we're not just exploring the unknown. We're exploring our own origins. We're asking the biggest questions. Where did we come from? Are we alone? What else is out there, waiting to be discovered? The journey to Pluto is just one chapter in the grand story of the universe. There are countless worlds left to explore, countless mysteries left to solve. And the best part is, the adventure is just beginning. If you have questions about Pluto, the Kuiper belt, or anything else in the universe, keep asking. Curiosity is the engine that drives discovery. Every great breakthrough in science started with a simple question. What if? Why not? How does that work? And if you ever feel small or insignificant, remember this. You are part of a universe that is vast, beautiful, and full of wonder. Your questions matter. Your curiosity matters. Together, we can keep exploring, keep learning, and keep reaching for the stars. Let's take a step back and think about what it really means to measure these kinds of distances and times. When we talk about traveling to Pluto, we're dealing with numbers so big, they're almost hard to imagine. 3,670,000,000 miles. That's a number that doesn't fit easily into our everyday experience. Even the fastest jet on Earth would take thousands of years to make the trip. So, how do scientists and engineers even begin to plan a mission like this? It all starts with understanding the basics of orbital mechanics, the rules that govern how objects move through space. Every planet, every moon, every spacecraft is constantly falling around the sun, pulled by gravity. To get from Earth to Pluto, you can't just point your rocket and go in a straight line. You have to follow a carefully calculated path, taking into account the movement of both planets, the pull of the sun, and the influence of other bodies along the way. This is why missions to the outer solar system are often launched during very specific windows, times when the positions of the planets line up just right. If you miss that window, you might have to wait years for the next opportunity. And once you're on your way, there's no turning back. Every maneuver, every course correction, has to be planned in advance, with almost no room for error. That's part of what makes these missions so impressive. The people who design and operate them are working at the edge of what's possible, using math, physics, and a lot of creativity to solve problems that no one has ever faced before. They have to think years, even decades, ahead. Imagine sending a spacecraft on a journey that will take 10 years, knowing that you won't see the results of your work until far in the future. It takes patience, dedication, and a deep belief in the value of exploration. And yet, every time we succeed, we open up a whole new world of possibilities. When New Horizons reached Pluto, it didn't just send back pictures. It sent back a flood of data that scientists are still analyzing today. Every image, every measurement, is a piece of a puzzle that helps us understand not just Pluto, but the entire solar system. Let's talk a little about what it's like to receive data from so far away. When New Horizons sent its first images of Pluto, the signal had to travel more than 3 billion miles to reach Earth. Even moving at the speed of light, that signal took about 4.5 hours to arrive. And because the spacecraft's transmitter is relatively weak, it could only send data at a very slow rate, about 1,000 bits per second. That's slower than a dial-up internet connection from the 1990s. It took more than a year for all the data from the Pluto flyby to be sent back to Earth. Scientists waited patiently, watching as each new image and measurement arrived, revealing more and more about this distant world. It's a reminder that space exploration is often a test of patience as much as technology. But the wait is always worth it. Every new discovery brings a sense of excitement and wonder. When the first close-up images of Pluto arrived, scientists were amazed by what they saw. The surface was far more varied and dynamic than anyone had expected. There were mountains, plains, valleys, and even signs of recent geological activity. It was a world that defied expectations and challenged our understanding of what's possible in the outer solar system. And it's not just Pluto. The Kuiper belt is full of objects that could teach us more about the history of the solar system. Some of these objects are thought to be fossils from the early days of planet formation, preserved in the deep freeze of space. By studying them, we can learn about the conditions that existed when the planets were forming and maybe even get clues about how life began on Earth. One of the most exciting things about the Kuiper belt is that it's still largely unexplored. We've only visited a handful of objects up close. There could be hundreds, even thousands, of worlds out there, each with its own story to tell. Some might have moons, rings, or even atmospheres. Others might be completely different from anything we've seen before. That's why scientists are so eager to send more missions to this distant region. Every new spacecraft is like a time machine, taking us back to the earliest days of the solar system. And every new discovery helps us piece together the story of how our cosmic neighborhood came to be. Now, let's talk a bit about the challenges of surviving in the outer solar system. The farther you get from the sun, the colder and darker it becomes. At Pluto's distance, sunlight is about 1,000 times weaker than it is on Earth. Temperatures can drop to nearly 400 degrees below 0 Fahrenheit. That's so cold that even gases like nitrogen and methane freeze solid. Spacecraft that travel to these regions have to be built to withstand extreme conditions. Their electronics have to be protected from the cold, their power systems have to work without much sunlight, and their instruments have to be sensitive enough to detect faint signals from far away. Many spacecraft use radioisotope thermoelectric generators, devices that turn the heat from decaying radioactive material into electricity. This allows them to keep working even when solar panels would be useless. And then there's the challenge of communication. The farther a spacecraft gets from Earth, the weaker its signal becomes. Engineers have to use giant radio antennas, sometimes as big as a football field, to pick up the faint whispers from deep space. Every bit of data is precious, and every message is a triumph of engineering. But despite all these challenges, we keep pushing forward. Every mission to the outer solar system is a testament to human ingenuity and determination. We're willing to face the unknown, to take risks, and to invest years of effort for the chance to learn something new. And what we learn doesn't just stay in the realm of science. The technologies developed for space exploration often find their way into everyday life. Advances in materials, electronics, and communications have all been driven by the needs of space missions. Even the way we think about our place in the universe has been shaped by what we've learned from exploring the cosmos. So, when we ask how long it would really take to reach Pluto, we're not just asking about travel time. We're asking about the limits of our technology, the power of our curiosity, and the lengths we're willing to go to answer the big questions. We're asking what it means to be explorers, to reach beyond what we know, and to imagine what might be possible. Maybe the next generation of spacecraft will use new forms of propulsion, solar sails, nuclear engines, or even technologies we haven't invented yet. Maybe we'll find ways to send probes faster, farther, and more efficiently than ever before. Or maybe we'll discover something so unexpected that it changes the way we think about the universe. Whatever the future holds, one thing is certain. The journey is just beginning. There are still so many worlds left to explore, so many mysteries left to solve. And every step we take brings us closer to understanding our place in the cosmos. One of the most exciting possibilities is the use of advanced propulsion systems. We've already talked about ion engines and solar sails, but let's dig a little deeper into what the future might hold. Imagine a spacecraft powered by a nuclear thermal rocket, where a small nuclear reactor heats up hydrogen and blasts it out the back at incredible speeds. This kind of engine could be twice as efficient as the best chemical rockets we have today, and it could cut the travel time to Pluto in half. There's also the idea of nuclear electric propulsion, where a reactor generates electricity to power ion engines. This would allow a spacecraft to accelerate slowly but steadily, reaching higher speeds over time. With enough power, a probe could reach Pluto in just a few years, opening up new possibilities for exploration. And then there's the truly futuristic concept of laser propulsion. Imagine a fleet of tiny spacecraft, each no bigger than a smartphone, equipped with a reflective sail. On Earth, a massive array of lasers fires beams of light at the sails, pushing them to a fraction of the speed of light. In theory, these tiny probes could reach Pluto in just a few months, sending back data at speeds we can barely imagine today. Of course, all of these ideas come with huge technical challenges. Building a nuclear rocket that's safe and reliable is no small feat. Creating a laser array powerful enough to push a spacecraft across the solar system would require new breakthroughs in energy and engineering. And communicating with a probe moving at such high speeds, so far from Earth, would push our technology to the limit. But that's the beauty of exploration. Every challenge is an opportunity to learn, to invent, and to push the boundaries of what's possible. The history of space travel is full of moments when people said, "That's impossible," only to be proven wrong by the next generation of dreamers and doers. Now, let's think about what we might discover if we could explore Pluto and the Kuiper belt up close, with more advanced missions. We already know that Pluto is a world of surprises, a place with mountains, plains, and a thin, blue atmosphere. But there's so much more to learn. For example, What's really happening beneath Pluto's icy surface? Some scientists believe there could be a hidden ocean of liquid water kept warm by the heat of radioactive elements. If that's true, it would be one of the most distant oceans in the solar system, and it might even have the right conditions for life, at least in some form we haven't yet imagined. And what about Pluto's atmosphere? It's incredibly thin, but it changes with the seasons, growing thicker or thinner as Pluto moves closer to or farther from the Sun. Studying these changes could teach us about the processes that shape not just Pluto, but other icy worlds in the outer solar system. Then there's the question of Pluto's moons. Charon, the largest, is so big compared to Pluto that some scientists call them a double planet. Charon has its own mysteries, a giant canyon, strange reddish patches, and a surface that looks very different from Pluto's. The other moons, Styx, Nix, Kerberos, and Hydra, are much smaller, but each has its own story to tell. Exploring these moons could reveal new clues about how the Pluto system formed and evolved over billions of years. And let's not forget the rest of the Kuiper belt. There are thousands of objects out there, each one a potential time capsule from the early days of the solar system. Some are as big as Pluto, while others are just a few miles across. By studying these objects, we can learn about the building blocks of planets, the history of our solar system, and maybe even the origins of life itself. Every new mission, every new discovery, adds another piece to the puzzle. And the more we learn, the more we realize how much there is left to explore. That's what makes science so exciting. It's a never-ending journey, full of surprises and new questions. Now, you might be wondering, why do we spend so much time and effort exploring places so far away? Why not focus on problems closer to home? That's a fair question, and it's one that scientists think about all the time. The truth is, exploring the universe helps us in ways we might not expect. The technologies we develop for space missions often find their way into everyday life. Things like better materials, improved communications, and new ways to generate and store energy. The challenges of space travel push us to be more creative, more resourceful, and more resilient. But there's another reason, too. When we explore the universe, we're reminded of how small and fragile our own world is. We see Earth as it really is, a tiny, blue oasis in a vast, dark cosmos. That perspective can inspire us to take better care of our planet, to work together, and to appreciate the beauty and wonder of the world we call home. And there's something deeply human about the urge to explore. It's part of who we are. From the first people who crossed oceans in tiny boats, to the astronauts who walked on the moon, to the scientists and engineers sending robots to the edge of the solar system, we've always been driven by curiosity and the desire to know what's out there. Right now, we're at the very beginning of a new era in exploration. Private companies are building rockets that can land themselves, new telescopes are peering deeper into space than ever before, and scientists are coming up with ideas that would have sounded impossible just a generation ago. Think about how much has changed in just the past few decades. In the 1970s, the Voyager missions gave us our first close-up look at the outer planets. Those spacecraft are still out there, traveling through interstellar space, sending back faint signals from billions of miles away. In the 2000s, New Horizons made its historic journey to Pluto, showing us a world more complex and beautiful than anyone expected. And now, we're talking seriously about sending missions to the moons of Jupiter and Saturn, searching for life in the oceans beneath their icy crusts. It's easy to forget just how quickly things can change. The technology that seems futuristic today might be routine tomorrow. When the first computers were built, they filled entire rooms and could barely do simple calculations. Now, you carry more computing power in your pocket than all of NASA had during the Apollo missions. The same kind of leap could happen with space travel. Maybe one day, sending a probe to Pluto will be as common as launching a satellite into Earth orbit. But even as technology advances, some things stay the same. The distances in space are still enormous. The challenges are still daunting. And the sense of wonder, The feeling you get when you see a new world for the first time never goes away. Let's talk a little about what it would take to make a human mission to Pluto possible. It's a dream that's still far in the future, but it's not impossible. The first step would be building a spacecraft that can keep people alive and healthy for a journey that could last 10 years or more. That means reliable life support systems, protection from radiation, and ways to keep the crew physically and mentally healthy during the long trip. We'd also need to figure out how to carry enough supplies, or how to recycle everything as efficiently as possible. On the International Space Station, astronauts already recycle water and air, and they're learning how to grow food in space. Those lessons will be crucial for any mission to the outer solar system. Then there's the question of propulsion. Chemical rockets are great for getting off Earth, but for a trip to Pluto, we need something faster and more efficient. That's where nuclear propulsion, ion engines, or even solar sails could come in. Each technology has its own challenges, but the potential rewards are huge. And finally, there's the human factor. Spending years in deep space, far from home, would be a test of endurance, teamwork, and resilience. Astronauts would need to be ready for anything: equipment failures, medical emergencies, or just the psychological strain of being so far from Earth. But if history has taught us anything, it's that people are capable of incredible things when they work together toward a common goal. Now, let's imagine what it would be like to arrive at Pluto after such a long journey. The approach would be slow at first, with Pluto just a tiny dot in the distance. But as you get closer, details would start to emerge. The bright heart-shaped region, the rugged mountains, the thin haze of the atmosphere. You'd see Charon, Pluto's largest moon, rising and setting in the sky. You might even see the faint glow of sunlight reflecting off the icy surface. Landing on Pluto would be a challenge all its own. The gravity is much weaker than on Earth, so you'd have to be careful not to bounce or tip over. The surface is cold and hard, covered in nitrogen and methane ice. But imagine stepping out onto that alien landscape, knowing you're the first human to set foot on a world at the edge of the solar system. Every rock, every patch of ice, every shadow would be a new discovery. And then there's the science. With instruments and tools, you could study the composition of the ice, measure the atmosphere, and search for signs of geological activity. You could drill into the surface, looking for evidence of a hidden ocean. You could set up experiments to see how the environment changes over time. Every day would bring new questions, new challenges, and new wonders. But maybe the most important thing you'd bring back from Pluto wouldn't be rocks or data. It would be perspective. Seeing Earth from so far away, just a pale blue dot in the darkness, would change the way you think about our planet, our place in the universe, and the importance of taking care of the only home we have. And that's really what exploration is all about. It's not just about going somewhere new. It's about seeing the world and ourselves in a new light. It's about asking questions, seeking answers, and never losing that sense of curiosity and wonder. As we look ahead, there are so many possibilities. Maybe the next mission to Pluto will be an orbiter, mapping the surface in detail and studying the atmosphere over time. Maybe we'll send a lander to dig into the ice, or a fleet of tiny probes to explore the Kuiper belt. Maybe we'll discover new moons, new geological features, or even signs of processes we've never seen before. And who knows, maybe one day, a new generation of explorers will set out for Pluto, not just as scientists or astronauts, but as ambassadors of humanity, carrying with them the hopes and dreams of everyone back on Earth. The universe is vast, and our journey is just beginning. Every question we ask, every mission we launch, every discovery we make brings us one step closer to understanding the grand story of the cosmos and our own place within it. So, as you go about your day, take a moment to look up at the sky. Remember that you're part of a universe that's billions of years old, filled with wonders beyond imagining. And remember that the spirit of exploration, the drive to know, to discover, to reach for the stars, is alive in you, too. There are astronomers who first spotted Pluto in the early 1930s, using telescopes that seem simple by today's standards. There are engineers who designed the first spacecraft to leave Earth's orbit, and scientists who spent years planning every detail of missions like New Horizons. But it's not just the experts who are part of this story. Every time you look up at the night sky, every time you ask a question about the universe, you're joining in. Curiosity is something we all share, no matter where we come from or how much we know about science. It's a universal language, one that connects us across time and space. Think about the first time you saw a picture of Pluto or read about the New Horizons mission. Maybe you felt a sense of wonder, or maybe you started to imagine what it would be like to stand on the surface of that distant world. That feeling, the spark of curiosity, is what drives all exploration. It's what led people to cross oceans, climb mountains, and eventually reach for the stars. And the amazing thing is, there's still so much left to discover. Even after all the missions, all the telescopes, and all the research, we've only scratched the surface of what's out there. The Kuiper belt alone is filled with thousands of objects we've never seen up close. Some of them might have their own moons, their own atmospheres, or even their own mysteries waiting to be solved. Every time we send a new spacecraft, we're opening a new chapter in the story of the solar system. Each mission builds on the work of those who came before, and each discovery inspires the next generation to keep asking questions. It's a chain of curiosity that stretches back to the earliest humans and will continue as long as there are people who look up at the stars and wonder. Let's talk a little about what it takes to keep that chain going. Science is a process, not just a collection of facts. It's about testing ideas, making observations, and being willing to change your mind when new evidence comes in. Sometimes, that means letting go of old ideas, like when astronomers realized that Pluto wasn't the only world of its kind and decided to call it a dwarf planet instead of a full-fledged planet. That decision wasn't easy, and it sparked a lot of debate. But it also opened up new ways of thinking about the solar system. Instead of seeing Pluto as an oddball, we started to see it as the first of a whole new class of objects. That shift in perspective led to new discoveries, new missions, and a deeper understanding of how planets form and evolve. And that's one of the most important lessons of science. It's okay to change your mind. In fact, it's necessary. The universe is full of surprises, and the only way to keep learning is to stay open to new ideas. That's true whether you're a professional astronomer or just someone who loves to look at the stars. Now, let's imagine what the next big discovery might be. Maybe a new telescope will spot a distant object in the Kuiper belt, one that's bigger than Pluto or has an unexpected orbit. Maybe a future mission will find evidence of a hidden ocean beneath Pluto's ice, or detect strange chemicals in its atmosphere that hint at unknown processes. Or maybe we'll find something so strange, so unexpected, that it forces us to rethink everything we thought we knew about the solar system. Whatever it is, you can be sure that it will lead to more questions, more missions, and more opportunities to explore. That's the beauty of science. It's never finished. There's always another mystery waiting just beyond the horizon. What can you do to be part of this adventure? You don't have to be a scientist or an engineer to make a difference. You can support science in your community, share what you learn with others, or just keep asking questions. You can look up at the night sky and wonder what's out there, knowing that you're part of a long tradition of explorers and dreamers. And who knows, maybe one day, you'll be the one to make the next big discovery. Maybe you'll invent a new kind of engine, design a mission to the outer solar system, or find a new way to study distant worlds. Or maybe you'll inspire someone else to do those things, just by sharing your curiosity and excitement. The universe is a big place, and there's room for everyone in the story of exploration. Whether you're building rockets, writing code, teaching science, or just watching the stars from your backyard, you're part of something bigger than yourself. Not long ago, Pluto was just a faint, moving dot in the sky, so far away that even our best telescopes could barely show it as more than a blurry smudge. For decades, it was a mystery, a symbol of the unknown, sitting quietly at the edge of our solar system. Then, with the launch of New Horizons, everything changed. Suddenly, we had a spacecraft racing across billions of miles, carrying cameras and instruments designed to reveal Pluto's secrets. When those first images came back, they stunned the world. Instead of a dull, frozen rock, we saw a world with mountains, plains, and a heart-shaped region that seemed to welcome us to this distant frontier. It's amazing to think that all of this happened because people were willing to dream big and work hard. The New Horizons team spent years planning every detail, solving problems, and making tough decisions. They had to wait nearly a decade for their spacecraft to arrive, and then they had just a few hours to gather as much data as possible during the flyby. It was a high-stakes moment, and it paid off in ways no one could have predicted. But the story doesn't end there. After Pluto, New Horizons kept going, heading deeper into the Kuiper belt. It visited Arikoth, a strange, snowman-shaped object that gave us our first close-up look at the building blocks of planets. Each new discovery added another piece to the puzzle, showing us that the outer solar system is far more complex and fascinating than we ever imagined. And that's the thing about exploration, it never really stops. Every time we answer one question, we find a dozen more waiting for us. Why does Pluto have such a thin, blue atmosphere? What causes the strange patterns on its surface? Could there really be a hidden ocean beneath all that ice? And what about the other objects in the Kuiper belt? What secrets are they hiding? These questions aren't just for scientists in labs or mission control rooms. They're for all of us. Every time you wonder about the universe, every time you look up at the stars and imagine what might be out there, you're taking part in the same adventure. Curiosity is something we all share, and it's what drives us to keep exploring, keep learning, and keep reaching for the unknown. Let's also remember that the story of Pluto is a reminder of how science works. It's not always a straight line from question to answer. Sometimes, we have to change our minds, rethink our ideas, and accept that the universe is more complicated than we thought. When astronomers decided to call Pluto a dwarf planet, it wasn't because they wanted to take something away. It was because they had discovered so much more. The solar system turned out to be richer and more varied than anyone had guessed, and Pluto became the key to a whole new frontier. That's the beauty of science. It's always growing, always changing, always open to new ideas. And that's why it's so important to stay curious, to keep asking questions, and to never be afraid of the unknown. Now, let's look ahead to what the next few decades might bring. With new telescopes coming online, like the James Webb Space Telescope and others still in development, we'll be able to see farther and in more detail than ever before. We might spot new objects in the Kuiper belt, or even find evidence of the mysterious Planet 9 that some scientists believe is lurking far beyond Pluto. At the same time, new missions are being planned that could return to Pluto, orbit it for years, or even land on its surface. Imagine a spacecraft that could drill into the ice, searching for signs of a hidden ocean, or a fleet of tiny probes exploring the Kuiper belt, sending back data that will keep scientists busy for generations. And who knows, maybe one day we'll find something so unexpected that it changes the way we think about the solar system all over again. That's the promise of exploration. The next big discovery is always just around the corner. But even as we look to the future, it's worth remembering how far we've come. In less than a century, we've gone from seeing Pluto as a distant mystery to exploring it up close, mapping its surface, and learning about its history. We've turned a tiny dot of light into a world with its own landscapes, weather, and stories. And through it all, we've been reminded of our own place in the universe. When you see a picture of Pluto or read about a new discovery in the Kuiper belt, you're seeing the result of countless hours of work, creativity, and curiosity. You're seeing what happens when people come together to ask big questions and search for answers. Seeing Earth from far away, as the New Horizons team did when they looked back from the edge of the solar system, is a powerful reminder of how connected we all are. No matter where you live or what language you speak, we all share this one home. And when we explore the universe, we're not just searching for new worlds. We're learning how to take better care of our own. That's one of the hidden gifts of space exploration. The more we learn about other planets, the more we appreciate the delicate balance that makes life possible here. We see how rare it is to have liquid water, a protective atmosphere, and the right conditions for life to thrive. And we realize how important it is to protect those things, not just for ourselves, but for future generations. But there's another lesson, too. When we reach out to places like Pluto, we're reminded that curiosity and imagination are some of humanity's greatest strengths. Every mission, every discovery, starts with a question: what's out there? How does it work? Could there be something we've never seen before? Those questions drive us to invent, to explore, and to dream bigger than we ever thought possible. And it's not just scientists and engineers who benefit from this spirit of exploration. The technologies developed for space missions often find their way into everyday life. From better cameras and medical devices to new materials and ways to generate energy, the ripple effects of space exploration touch us all. Even the way we communicate, navigate, and understand our world has been shaped by the quest to explore the cosmos. Let's not forget the role of teamwork in all of this. No one person could send a spacecraft to Pluto or decode the mysteries of the Kuiper belt. It takes teams of people, often from all over the world, working together, sharing ideas, and solving problems. That spirit of collaboration is one of the most powerful forces in science, and it's something we can all learn from, no matter what we do. Now, let's look ahead to the next generation of explorers. Maybe you're a student, a teacher, or just someone who loves to learn about the universe. The questions you ask today could lead to the discoveries of tomorrow. Maybe you'll be the one to design a new kind of spacecraft, or to find a new way to study distant worlds. Or maybe you'll inspire someone else, just by sharing your curiosity and excitement. The future of space exploration is wide open. New missions are being planned all the time, and each one brings us closer to understanding the universe and our place within it. Maybe the next spacecraft to visit Pluto will carry instruments we haven't even invented yet. Maybe it will find evidence of a hidden ocean, or discover new moons, or reveal processes we've never seen before. Think about how much we've learned just by sending a single spacecraft to Pluto. Before New Horizons, we could only guess at what the surface looked like, what the atmosphere was made of, or how many moons Pluto had. Now, we have detailed maps, close-up images, and a much deeper understanding of this distant world. But even with all that new information, there are still so many mysteries left to solve. For example, scientists are still trying to figure out exactly how Pluto's heart-shaped region, Tombaugh Regio, formed. Is it the result of a giant impact, or is it shaped by slow, ongoing processes beneath the surface? And what about the strange, polygon-shaped patterns on the icy plains? Are they caused by convection, where heat from below slowly moves the ice around, or is something else at work? Then there's the question of Pluto's atmosphere. We know it's thin and mostly made of nitrogen, with traces of methane and carbon monoxide. But it changes over time, growing thicker or thinner as Pluto moves along its long, oval-shaped orbit. Sometimes, the atmosphere even freezes and falls to the surface as snow. Understanding these changes could help us learn more about other icy worlds, both in our solar system and beyond. And what about the possibility of a hidden ocean beneath Pluto's icy crust? Some scientists think there could be enough heat trapped inside Pluto to keep water in a liquid state, even so far from the sun. If that's true, it would be one of the most distant oceans in the solar system, and it might even have the right conditions for life, at least in some form we haven't yet imagined. These are the kinds of questions that keep scientists coming back for more. Every new discovery leads to new ideas, new experiments, and new missions. And as technology improves, we'll be able to explore Pluto and the Kuiper belt in ways we can only dream of today. Let's imagine what some of those future missions might look like. Maybe the next spacecraft to visit Pluto will be an orbiter, circling the planet for years and sending back data on its surface, atmosphere, and moons. Or maybe we'll send a lander, equipped with drills and sensors to search for signs of a hidden ocean. We might even send a fleet of tiny probes, each exploring a different part of the Kuiper belt, mapping out this mysterious region in detail. And it's not just robots that could make the journey. As we develop better propulsion systems and life support technology, the idea of sending humans to the outer solar system becomes a little less far-fetched. It would be the ultimate adventure, a journey to the edge of the sun's influence, to a place where no one has ever been before. Of course, there are huge challenges to overcome. The distances are vast, the environment is harsh, and the technology would have to be incredibly reliable. But if history has taught us anything, it's that people are capable of amazing things when they work together and refuse to give up. And that's really what the story of Pluto is all about. It's a story of curiosity, perseverance, and the power of imagination. It's a reminder that the universe is full of surprises, and that the only way to find them is to keep exploring, keep asking questions, and keep reaching for the unknown. The challenges of reaching Pluto have pushed us to develop better engines, smarter computers, and more efficient ways to communicate across billions of miles. For example, the radioisotope thermoelectric generators that power spacecraft like New Horizons are a direct result of the need to explore places where sunlight is too weak for solar panels. The software that helps a spacecraft navigate and operate on its own, far from Earth, has led to advances in artificial intelligence and robotics. Even the way we process and share data has changed, as scientists around the world work together to make sense of the information sent back from the edge of the solar system. And it's not just about technology. The story of Pluto is also a story about patience and persistence. Imagine working on a mission for years, maybe even decades, before you see the results. The people who built and operated New Horizons had to wait nearly 10 years for their spacecraft to reach Pluto, and then another year to receive all the data. That kind of dedication is rare, but it's what makes big discoveries possible. There's also something deeply inspiring about the way these missions bring people together. Scientists, engineers, students, and even people who just love space all share in the excitement of a new discovery. When the first images of Pluto arrived, people all over the world stopped what they were doing to look at a world no one had ever seen before. For a moment, we were all united by a sense of wonder and curiosity. That feeling of being part of something bigger than yourself is one of the greatest gifts of exploration. It reminds us that, no matter how different we might seem, we all share the same sky. We all have questions, dreams, and the desire to know what's out there. Let's also remember that the story of Pluto is still being written. Every year, new discoveries are made, new missions are planned, and new questions are asked. The Kuiper belt is still a frontier, full of surprises and mysteries. Some scientists believe there could be thousands of objects out there, some as big as Pluto or even larger, waiting to be discovered. And then there's the possibility of finding something truly unexpected. Maybe a new kind of chemistry, a strange new moon, or even signs of processes we've never seen before. The universe has a way of surprising us, especially when we're willing to look in places no one has looked before. These aren't fantasy missions, they're being seriously proposed. Scientists are sketching out engines that could handle the extreme cold, instruments that could peer beneath the ice, and communication systems that could send signals back from billions of miles away. And when you hear them talk about it, there's something exciting in their voice, something deeply human. That feeling of building a bridge between the known and the unknown. You see, exploring Pluto isn't just about data. It's about discovering something no one has ever seen. It's about turning a spark of curiosity into a reality. It's about taking something that started as a question and arguably a dream and turning it into action. And that action inspires more than just scientific progress. It inspires culture, art, music, even philosophy. Writers imagine alien landscapes based on real features of Pluto. Artists paint tumbling moons and icy plains. Students daydream about becoming planetary geologists or spacecraft navigators, or the first person to walk on a world 4 billion miles away. We often think of space exploration as technical, and it is, but it also touches something emotional. It reminds us we're part of something bigger, something ancient and vast and incredibly beautiful. And it keeps us humble. Because, let's be honest, when you're looking at a world so distant that light itself takes hours to get there and hours to return, it does something to your sense of time and space. It stretches it. You start to see your life, our planet, and all of human history for what they truly are, tiny threads in a much larger story. But here's the amazing part. That tiny thread matters. Earth may be small compared to Jupiter, or tiny next to our sun, or invisible compared to the scale of the galaxy, but it's home to something rare. Thinking minds. Question-asking, wonder-loving, mystery-chasing minds. The kind of minds that launch ships beyond the edge of visibility, chase ice and gas through the blackness of space, and whisper across 3 billion miles to say, "We're here." We did that. We've already done it. And the question is no longer, can we explore the outer solar system? It's how far we want to go, how much we're willing to put into the journey, and what kind of explorers we choose to be. Because there's another truth, and this one's just as powerful. We're barely getting started. There's Planet 9, still unseen, but maybe out there, tugging gently on the orbits of distant objects, hiding behind a curtain of stars. There are dwarf planets we don't even know about yet, slipping quietly through the darkness, just waiting for someone to notice. And maybe, just maybe, there's something even stranger out there, something that doesn't fit neatly into our classifications, something that will surprise us just the way Pluto did the first time we saw its craggy, icy surface and realized it had mountains, plains, and geological activity no one expected. That's what exploration is all about. It's about opening yourself up to surprise, to being wrong in the most exciting way, to letting the universe teach you something you never thought to ask. And when you think of it like that, Pluto starts to become more than just a destination. It becomes a symbol of how far we've come since the first astronomers guessed that something might be lurking beyond Neptune. A symbol of how a tiny, icy world defied expectations again and again. And most of all, a symbol of what we can accomplish when we follow a question all the way to its billions of miles away answer. We still don't know how long it'll take to reach Pluto with future tech. It might drop from a decade down to 5 years. Maybe one day we'll scrape it down to 1. But in a way, the time isn't the most important part. Because whether it takes 5 years or 50, what matters is that we choose to make the journey.